Hey everyone, welcome back to Excel Panda, and today we are going to solve this Leetcode problem 3195, and it's a very simple problem, right? But very important problem because it will teach us how to calculate the bounding rectangle. Okay, and bounding rectangle means, let's suppose if you want to calculate uh, the rectangle of some points in the grid, right? Uh, so there is a concept that appears again in a harder geometry and the matrix problem that we will talk here. So very first, you just think that we have given a 2D grid we have given, and it's filled with zeros and ones we have here in the grid. And what we need to do, we have to find the smallest rectangle which sides are parallel to the grid that covers all ones, right? That is why the question is saying that we have given a 2D array that is called grid, right? It's a binary array grid we can say, and we have to find the rectangle horizontal and vertical sides with the smallest area. Okay, so that is why I'm saying we have to find the smallest rectangle with the side should be parallel to the grid, right? And that covers all ones we can say. Okay, and we will return the area of that rectangle. So this is the problem that gives you that there is at least one uh, should be in the grid. Okay, understand? Okay, so let's try to understand with this grid, right? Very first, we need a rectangle that covers all one s, right? Let's suppose for this case, and this. Okay. Very first, topmost row is at where? At row 0. Can say that. What is the topmost one we have here? It is at row 0. Can we say that? And the bottommost ones are where? At column 2 we can say here. Column 0, column 1, column 2, we can say that, right? Are the row 1 and row 0, C1 and C2. Okay, so this one that we have at row 0, can we say that? Our topmost one at row 0. Then we can say we have another one here at the bottommost, right? One. It is at where? Row 1. It is at row 1. Okay. Can we say that? One is at row 0, another is at row 1. Can we say that? We can say that, right? Next, we can say we have the one is at column 0. This case, for this, it is at column 0, right? And here, the rightmost one we have at column C2. You say that? You can say that, right? So the rectangle that it forms, or you can say from 0, 0 to 1, 2, right? Very first, when we talk about at here, so we'll start from here, right? 0, 1, 2, right? This is what our, this is 1, can say for the row 1, can say for this case, matrix. Very first, this is our row 0, can say 0 because its column is 0 and this row is 0, right? You can say this is your 0, 0. 1, we'll say 1, right? Like that we can say. So for this, it will become 0, 1. For this, it will become 0, 2. And for here, it will become what? 1, 0, 1, 1, and 1, 2. Can I say when we talk about if you want to form the rectangle, as you can see, it is having the red color, right? Can we say the rectangle that we can form from here, from here 0, 0 to 1, 2, means this cell to this cell can form the rectangle. That is why it look like a rectangle, right? Correct, because we have 2 rows and 3 columns. That is why it is making what? Rectangle, not the square, right? Here we can say from here to here we'll consider the as a height. Can we say that? And its height is nothing but we talk about the width from here to here. What is the width here? Width is 3. Can we say that? So what is the, what you call, area, right? Area is height into width. 2 into 3 is equal to 6. Can we say that? What we have. So we can say the topmost ones, right, is at row 0. This is at bottommost one is at row 1, right? And also we can say the in the case of all columns, right, we can say the leftmost one is at column 0, rightmost one is at column 2, and so it forms as a grid, rectangle grid. And so we can say if you find the area like this, that is why if you see it is coming 6. Similarly, let's talk about this grid. In example we have, right, and we can talk about this. Okay, very first we have given 0, 1, 0, 0, 0, right? So here only one we have here. There is only one s is existing here at where? At 0, 0. Can we say that? So the rectangle, we can say, is nothing but this itself, we can say, right? So height is what we have is 1, width is 1. We'll say area will become what? Multiply 1 into n. 1, 1. What we will get? 1. And that is why our answer is 1. Okay. So the question is, what will be our approach? So how do we solve this in general, right? So let's understand the idea. Very first, I can say you have to find the what? Minimum row that contains 1, right? What is the idea? You have to find the minimum row. You can say you have to find the minimum rows minimum row that contains what? A 1. Can we say that? Then we have to find the maximum row, right, that contains what? A 1, right? So once we will find it, we know that we can maintain the height. So for that we can get the height. Can we say that? And we know the maximum row. If we find the maximum row, we'll do the minus with the minimum row. Can we say that? Mathematically, to do the minus, you will just add 1. So we will get the, because we start from 0, right? But we can say we'll just add 1 and we'll get the height, right? Similarly, if you want to find the width, right, you will find the max column and mean column, right? And you will do plus 1. Once both are found, just you need area to multiply height into width. So very first you have to find the minimum row and maximum row, right? Similarly, you have to find the what? Minimum, maximum. Similarly, you have to find minimum row we have find. Then we have to find the minimum column and maximum column, right? That contains what? With value should be 1. If all we will find, we should be able to find the width, height and width. Once we will find the width, we'll just find the area. Once it is done, we are done. Okay, let's understand how. So very first, okay, as you can see, we have to find what? We have to find the mean row, right, and mean column. We have to find max row and max column. So if you have the max row, mean row, max column, mean column, right? How you are going to find that? You will go through the all the what you call the grid value, right? And then you will find the min row and max row, min call and max call, right? You will each time you will pass the min row and ij you will pass, right? This is nothing but your what is this? This is your you will find the at the grid at some, if the grid at uh, cell at value is equal to 1, you can find these values, right? Compute the height. As you know, we compute like this: width and column. From width will get from the column and height will get from the row, and once it is done we just return multiply. That's all we have here. But if you feel any doubt, please ping me in the comment box. So if we talk about, we can scan this entire grid, right? In of m cross. If this is m, suppose m, this is n, so you can say m cross n time it will take, because we have to take for both cells, because we are moving on the grid. On the moving on the grid, we have to take the time complexity O into n cross m time, we can say that. So it will perfectly, it will work for let's suppose for it was saying the size could go what 1000, right? So okay, 1000 into 1000 grid size, it will work perfectly. It will not give you any issues, so we can say this is good for us. Okay, so that's it. We are just solving we have solved this problem, right? And we have used the bounding rectangle approach. So whenever you see the problem that covers enclosing points, right, in a grid, you should think about the mean and the max boundaries, as we have uh, found, right? So we can, if you have the mean and max, right, you can easily find required things, like in this case we need the height, so, and the width. So that's all. So if you found this video helpful, don't forget to like, share and subscribe.